Hello everyone, thank you for joining this webinar on where science meets mould. Perhaps more accurately, we should have called it where chemistry meets mould. There's several chemical solutions which are used in mould removal, from householders through to mould remediation professionals. The ability or the performance of these chemical solutions to in fact kill the mould microorganism is still a hotly debated subject and a topic of much misunderstanding. My name is Everard Painter, the Managing Director of Actichem, and I'm going to talk you through this discussion today. While there's been a massive amount of resource apportioned to the investigation and science of moldicides and I should say disinfectants in relation to viruses and bacteria, there's been relatively little resources apportioned in science to the ability of chemicals to kill mold. This is a contributing factor to the many false and misleading statements that we see, videos and statements made on the internet, even by relative professionals in relation to the ability of chemistry in the mold remediation sector. Today's discussion will focus on the pertinent points relating to moldicides and the ability of chemistries to kill mold. Actichem has put together a compelling and very enlightening presentation today in relation to this, based on a significant amount of resource being put into the test work that's been done by NATO-accredited laboratories on this very subject. So the result is a very enlightening picture, which certainly lifts the lid on the truth of killing mold with chemicals. So to get us all onto the same page, we'll just go through some of the background principles in relation to moldicides and in relation to the killing of mold and fungi and bacteria. We'll start off with an overview of microorganisms. The reason for this is just to show exactly where mold and fungi fit in relation to bacteria, viruses, right up to bacterial spores. And then we'll take a very interesting look at the ability of how disinfectants are tested. We'll also, prior to that, have a look at the kill rates, understanding their significance and how we interpret these results when we see them. And finally, the very enlightening results of the lab test work, which have had done over the past 12 months, which has been done on a selected variety of chemistries, including things such as vinegar and chlorine, hydrogen peroxide, and then drawing a line alongside of them with the Actichem solutions. So to have a look at microorganisms, microorganisms or pathogens are simply germs, as they're commonly known, are the microscopic cells or colonies which cause disease. They are not the disease themselves, but they're the microbes which cause this disease. So if we have a look there, we're right at the bottom there, we've got the SARS coronavirus. That is the virus, the disease which causes is COVID-19. The same with HIV, that is the virus, the disease it causes is AIDS. What we've got there is a list of these types of microorganisms in order of their sensitivity to being deactivated by the three main ways that microbes are deactivated. That is UV, e.g. sunlight, right through to UV treatment in hospitals, etc. And the second one is heat, and the third one is chemicals. So as we can see on the table there, enveloped viruses or lipid viruses are the most easy ones to knock out with a disinfectant or with UV or with heat, and then running up there to prions, which is something typically really only found in hospital theatres and this sort of thing, that are very, very difficult to deactivate. The interesting thing is that some of the most prevalent microorganisms that we see or hear about are in fact the easiest to kill with using deactivation methods. Enveloped viruses, then we've got our vegetative bacteria such as E. coli and Salmonella and Pseudomonas aeruginosa, Staphylococcus, etc. Then the one that we're interested in today is the fungi, and this includes yeasts and molds. A point of note is that yeasts are typically easier to deactivate than molds. Now, some molds are particularly difficult to kill. Now, commercial grade disinfectants have to be tested to be able to kill vegetative bacteria. And by definition, they would typically be able to remove enveloped viruses because they want down on the table there. Hospital grade disinfectants are more effective and would mostly be effective on fungi to a point. Certainly all your yeasts and many of your molds, but not necessarily all of them. Hospital grade disinfectants are certainly a good way to go with mold remediation, but they're not a guarantee that all your molds are going to in fact be killed by them. Kill claims and log reduction. Log reduction is a mathematical term used to describe the quantity of microorganisms which are eliminated by a disinfectant solution, and it directly corresponds to the percent eliminated. So mostly in the market, we hear about the percent eliminated, which is 99% or 99.99% or 99.999%. And they are a direct correlation. As you see on the top left-hand side in a table, a 5 log reduction gives us 5 nines. So that's just an easy way of remembering it, or 4 log gives us 4 nines. Now, the amount to note is the number of microorganisms remaining. So 99.99%, yes, certainly that sounds like it's a lot of microorganisms that have been killed. But in actual fact, we've still got 1,000 remaining. And they are the ones that are typically the most difficult to knock out too. So as we go down, we'll see it's a factor of 10. And the interesting thing to note is that 99.99%, as we got in the paragraph there, kills 10 times more microorganisms than 99.9%. It's not just simply 0.09% stronger. So a very, very important point to understand what we are talking about when we see the difference between a disinfectant that kills 99.9 or 99.99%. The fact of the matter is that we're talking about a 10 times difference. When we have a look at disinfectant testing, this is where some of the most interesting data comes in as a result as to how the test methods are actually run. I don't know how many of you guys have bought a ute before, but if you've got a ute, a 1-ton ute, that is what it is advertised as. How does the manufacturer actually come up with that test? How does the manufacturer actually come up with that weight limit? Puts a ton of gear on the back of a 1-ton ute, drives it around the car park, and yeah, it holds 1 ton. The axle hasn't broken, the wheels are still on, the tub hasn't crumpled. So that is his method, you might say, of saying, yeah, it's a 1-ton ute. Absolutely, it holds 1 ton. But what he's not telling you is that how's it going to go when you are carrying 1 ton of firewood through the bush, or trying to take 1 ton of gear on the back of your truck, or let's say some building sand through a building site over all the rough roads, or maybe 1 ton of product on the freeway at 120 k's an hour. So the 1 ton test that was done around the car park doesn't give us a true picture of how that 1 ton is going to look in use as the ute is actually used in every day. So the same thing really applies in relation to test chemicals, in relation to disinfectants, and this is the interesting thing, and this is why I wanted to bring this up, is that there is 2 test methods in relation to testing disinfectants. The first one is a quantitative suspension test, and the second one is the hard surface carrier test. So the quantitative suspension test is kind of like the ute's 1 ton ute being driven around the concrete car park and established that, yes, it can handle 1 ton worth of loading. So the quantitative suspension test is saying, yes, we are able to kill these bacteria, these molds, these viruses, or whatever it is, with this disinfectant. It's established that that is the point, but it doesn't tell us as to whether this is going to be a true reflection of what it's able to do in real life. When those viruses, or in this case we're talking today, when those molds are actually embedded in a wooden stud frame of a house, or in the paintwork of a gyprock wall. The second test is a hard surface carrier test, and that test was developed specially to provide us with a more accurate assessment of the chemical's ability in real life. Unfortunately, because the quantitative suspension test is a test which is obviously easier to pass, it is easier to get results from, that is the test results that are often described on marketing literature. Yes, this chemical achieves a 99.99% kill rate, but it's not telling us how well that is going to be achieved in real life. So what the TGA has done in Australia, and it's the same with many other organizations, similar organizations or authorities around the world, is that the suspension test is only good enough if you are talking about a commercial grade disinfectant or household disinfectant. When you are wanting to get a hospital grade disinfectant listed, you have to also pass a hard surface carrier test. That makes it more realistic. So this is very, very pertinent in relation to mold remediation. Unfortunately, TGA regulations don't really apply or not really required by legislation in the sector that we're working with in relation specifically to mold. So yes, there is quite a bit of false advertising essentially out there, which can be argued that it's not false because it's got the quantitative suspension test, but it doesn't actually tell us what the true story is in real life. Now, the other test method variables which you need to be aware of is for every one of these tests, both the quantitative suspension test or the hard surface carrier test, they can be run clean or dirty. So that means that the test is run with no interfering substance. On the dirty test, they actually apply a certain amount of albumin into the solution, putting this interference substance in there to try and make it as hard as possible for the disinfectant to do its job. So that dirty test replicates what would happen if there is dirt on the surface that you are cleaning, removing the mold or even the bacteria, which, as we know, is a very, very relevant part of cleaning mold in real life. There is always dirt on those surfaces along with the mold. That's just part and parcel of it. The other thing, of course, is the dwell time. Some people will brag about a 60-second dwell time. That's great, but how much log reduction or percentage kill are they getting at that short dwell time? Was it in fact done on a clean test or a dirty test? So you have to look at all three things together, whether it's done on a clean test, what the log reduction is, and the dwell time. Those three things go together. So dwell time is very important to have a look at. In our sector, there's not a huge amount of advantage in talking about a 60-second dwell time as being fast. We've got the time to wait the 10 minutes and achieve the high rate of kill and on a dirty surface. We're in real life situations here. If we have a look at the suspension test literally takes the microorganism and has it suspended in that test tube with the disinfectant. That's great if we're talking about mold in a pool, because that's literally what's going to happen. But it's not what's going to happen on a typical hard surface. So that is the suspension test, which is widely used as an initial testing. You might say an initial challenge test to see as to whether your chemical will in fact be effective against a particular microorganism. The second one, which we rely on, is the hard surface carrier test, where a hard surface, in this case, it is namely a metal disc, a stainless steel disc, is inoculated with the mold or the bacterial, the virus, and then the disinfectant is applied to that disc. And given the dwell time and then deactivated and the remaining spores reactivated to get some calculation as to how effective that disinfectant process has been. The other thing with this hard surface carrier test, however, is you can also stipulate that it gets agitated. In all of our tests, we take it that there's no agitation given to give it the most real life parameters so that it's true to what we are able to actually do in real life. Let's have a look at the actual chemistry and the effect of these various chemicals that we all are very familiar with. How many microorganisms do they actually kill? How effective are they in actual fact at killing molds? The three chemicals we initially got tested, or we've got up on the screen there, is the white vinegar. Why did we get white vinegar tested? Because that is what a lot of householders use. There is even a lot of mold remediation professionals who use white vinegar, believe it or not. And in all due respects, to a lot of homeowners, maybe that's all they've got available. The second one is hydrogen peroxide 8%. Now, this is straight hydrogen peroxide 8%. It's just literally hydrogen peroxide diluted down with distilled water to that percentage. And the same with the chlorine or the bleach or the sodium hypochlorite, whichever name you'd like to call it. So the parameters are dwell time 10 minutes, conditions dirty. On our suspension test on the white vinegar, we are getting a less than 3 log reduction on the aspergillus and less than 3 log reduction on the penicillium. So we've got 2 microorganisms tested there. The hydrogen peroxide is giving us less than 3 log on aspergillus, less than 3 log on penicillium. And chlorine is not doing too badly. It's giving us a greater than 4 log reduction of each of those. So out of interest, 3 log reduction actually passes many of these moldicide tests. The EN1650, the limit there is in actual fact a 3 log reduction, 99.9%. So it actually passes on a suspension test. However, let's have a look at what happens when we do a hard surface carrier test on those exact same chemicals, same conditions. Note how with white vinegar, the log reduction suddenly drops down to 1.3 log for aspergillus or 2.1 log for penicillium. All of a sudden, white vinegar becomes very, very ineffective when we put it in a true life situation. The interesting thing about it too is that aspergillus is one of the low moisture molds. That is what is typically found in houses where people are living. And this is the ironical thing, that it's white vinegar that they're using in many cases to knock it out. And white vinegar is largely ineffective on most of your aspergillus microorganisms. White vinegar is only effective on around about 80% of mold types. Hydrogen peroxide is just a straight 8%. Once again, it's not doing too badly on a suspension test, but look how it drops down in the carrier test. Now, a lot of this is as a result of the high surface tension of hydrogen peroxide and also the high surface tension of chlorine, which drops down remarkably quickly as well. An interesting thing about white vinegar, however, is that white vinegar has actually got fairly good surface tension. It is actually quite good on that, because molds typically have a very high surface tension, so you need something to wet them out properly. However, all of those 3 chemicals are fairly ineffective at killing mold on their own when you test them in real life conditions, aka the hard surface carrier test. Let's have a look at the 3 predominant chemistries that are used from Actichem on mold remediation. The Actichem Percide first up gives us a greater than 5 log reduction. That may even be up to 6 log reduction. That is very, very effective on both the suspension test and on the carrier test. So we're still getting very, very powerful results on our true life situation when it's done according to the carrier test. Now that's Percide on its own. When we do the Percide Plus Boost, which we always recommend when there's a high volume of dirt along with or soiling along with the molds, and also when we have a situation where there's just a high mold buildup, we add the Percide Plus the Boost, and we're getting an even more powerful killing of molds, right up to a 6 log reduction, which makes it a complete wipeout of the molds on those subjects. Now, remember that the high reduction of surface tension is making it very effective in those real life situations, even on porous surfaces, going right into the pores of those surfaces to eradicate the roots and the spores. Now, one thing that's very important is that all of this mold testing was done on a combination of mold spores plus the vegetative form of the mold. So it gives us a very good real life profile of testing. The last one is the mold exterminator, which is based on chlorine. As you would expect, it gives us a greater than 4 log reduction in a suspension test, and that may even be up to 5 log. On the carrier test, it still performs extremely well, giving us a very, very effective means of killing mold. However, of note is the sheer pure strength of the Percide, which even beats these chlorine-based chemistries. Very, very effective, the Percide mix. It gives us a very enlightening, very, you might say, myth-busting, lift the lid kind of look at these disinfectants and the ability of chemicals to treat mold. Absolutely, chemicals are effective at killing molds, very, very effective moldicides, but you have to be selective in what you use. Because the mold stain is gone, doesn't mean that the mold has been removed, has been killed, especially down to the roots. A lot of literature, I'm sure from now on, you'll be able to read more intelligently, get more out of it, have a better understanding, and have more intelligent, you might say, discussions with your client in relation to the mold on their particular job or in their home. A lot of the answers are going to be found that we spoke about today in this Disaster Restoration Handbook, which is a publication that we recently released at the RIA show. The RIS is available. It's available online, an absolute great resource where it brings together all the training, you might say, from the IICRC courses and ties it together with the actual chemicals that are available in the field. So this doesn't replace the ICRC courses. We've got some great teachers out there that teach them. This is a complementary publication where it ties that together to the chemicals and how you can use them, dilution rates, etc., etc. Very, very valuable publication that. Thank you very much, everybody. We really appreciate you joining, and we look forward to seeing you, as I say, once a month on these very instructive and interesting, enlightening webinars. Thank you.